Hello students, welcome to my YouTube channel Electrical Engineering. In this lecture, I am going to demonstrate Newton Raphson method for solving non-linear problems. Newton Raphson method is the most popular method for finding the roots of non-linear complicated equations. This method has also several uses in power system modeling, power flow solutions, and other engineering problems. The basic algorithm of Newton-Raphson method starts by the Taylor series expression. Suppose this blue curve is our original nonlinear function whose root is to be determined. The root of this uh, original function is lying at this point x steric. We have to first specify the initial guess, which is x naught, and after implementing the algorithm repeatedly, the solver should converge and it should reach the destination, which is x steric. Now, first we have to consider the Taylor series expansion of any mathematical function. The Taylor series expansion is given by this equation 4.1. If we ignore all other second order and higher order terms, we get this expression up to this point. Now, this is a first order equation, which is also called a linear equation, and it represents a straight line. In this equation, we have to substitute fx equal to 0 because when x naught is our initial guess in this figure, when x naught is our initial guess, then this equation belongs to this straight line, which is starting from this point x naught. When we equate this equation to 0, it means we are representing this point. Now, this equation is similar to the y-intercept form of a linear equation, which is y is equal to mx plus c. So this is fx naught, which is c, or it can also be termed as the y-intercept. This is the slope of the function at this point x naught, and this is x minus x naught. Now, if I equate this y to 0, it means I am finding the zero crossing of this straight line, and this straight line has this equation. So the new point x which I obtain is actually n plus x n plus 1, which is my new point, and this point is equal to xn minus f of xn divided by f derivative at xn. Now I will substitute this point into my original function, and I will see if the solution of my actual equation exists at this point or not. If my solution exists, then the solver should terminate the iterations. Otherwise, it should continue its iterations and evaluate new x. And this process will go on. Now we can implement this algorithm in MATLAB using this simple and straightforward algorithm. Here I am using symbolic math toolbox of MATLAB. I will define my actual mathematical function using this command. This command is used to evaluate the derivative of this function. The actual form of this mathematical function is shown over here. X plus 10 raised to power minus 6 exponent 80x equal to 5. This is the same expression, but this 5 at the right hand side is shifted towards left. So it will become minus 5 and right hand side will become equal to 0. So x plus 10 to minus 6 exponent 80x minus 5. This is the derivative of this expression. This is my initial guess. This is my initial error which I have specified as 1, and I will use this count variable to calculate the total number of iterations. Now I have used a while loop over here. As long as my error is greater than 10 raised to power minus 6, the simulation will not stop. Then this is the Newton Raphson algorithm to calculate the new x, and I will calculate the error in x and error in the function. Both of these errors should be minimum, and when this error is smaller than or equal to 10 raised to power minus 6, my iteration will stop. So let's run this code. When I click on this run button, I get this solution 0.19232, and the total number of required iterations are 69. Similarly, I can use any other nonlinear mathematical function to calculate its roots, and Newton-Raphson method will give us the required result. Now, clearly in this equation, we can see this is a nonlinear equation, and it is impossible to calculate the value of x by conventional analytical methods. So in solving such equations, we have to use Newton-Raphson method. I hope you have enjoyed this lecture. For watching more similar videos, please stay tuned to my YouTube channel. Until the next lecture, it's goodbye.